Welcome to Char, GATE ESE lecture. We are in lecture number 90 of PDC. Now this is the 6th module, that is our FET. Now here we are going to discuss about output characteristics curve. Output characteristics curve. Now this lecture is going to be extremely important for the JFET subject. Now listen, we have two curves. One is your output current versus output voltage. Your output voltage is your VDS and output current is your ID, VDS, output and output. Then this will be regarded as output characteristics curve. And if you have a output current and input voltage, then that will be regarded as transfer characteristics curve. This video lecture will be on output characteristics curve. That means it will based on this curve. Okay, we'll analyze this curve, and after this video lecture, in the next video lecture we'll get into the transfer characteristics curve. Transfer characteristics curve. Now let's start with output characteristics curve. Look here carefully. This is your output characteristics curve. Okay, here output current and your output voltage. Here at VGS equals to 0 volt, you will get a graph like this. I have made this as a solid form in order to avoid the drawing pattern, because ये actually curvy nature में है, but solid में आपको थोड़ा अच्छा दिखेगा, इसलिए I adopted the solid pattern. Okay, so but यहाँ पे सब sublinearity है. This is actually curve in the nature. Okay, now look here carefully. I have drawn VGS value for 0 voltage, VGS for 0 volt. By fixing VGS as 0 voltage, by varying VDS value, you'll get ID value like this. Look, हमारे हाथ में VGS है. VGS is our input side. You'll have a proper clarity in your transfer characteristics in the transfer characteristics curve video lecture. In the next video lecture, we're going to have a pure clarity on these two curves, but right now try to understand this curve only. So once I start decreasing the VGS value from 0 voltage, -1, then -1 to -2, -2 to -3, slowly our graph will changes like this. For VGS 0 volt, the graph will be like this. For VGS equals to 1 volt, -1 volt, the graph will be like this. This is for N channel. My dear friend, this is for N channel JFET. Okay, for P channel JFET, this value will be more positive. But here the values are getting more negative. Okay, now all these points, the points of voltage value, or the voltage value at which your current became constant, that point will be regarded as, sir, pinch of voltage. Absolutely correct. There will be another pinch of voltage here, there will be another pinch of voltage here, there will be another pinch of voltage here. So there will be lots of pinch of voltage like VP1, VP2, ऐसे करके काफ़ी सारे pinch of voltage आपको मिलेंगे. Now ये जितने भी points है, अगर आप इनको combine करो, इसके locus will form the slope of this locus will form a V proportional to I वाला characteristics. That is your ohmic behavior यहाँ पे. So that is why we consider it as, look here carefully, this region is considered as, this region is considered as, this region is considered as, this region is considered as ohmic region. Okay, because this region you will get for several value of VGS, several values of VGS, 0 volt, -1 volt, -2 volt, you will get ohmic behavior. That is your V proportional to IK characteristics. So this is your A region, that is your ohmic region. There will be a B region here, there will be a C region here, there will be a D region here. At B region, you'll get a saturation point, saturation value of current, saturation value of current. So at B. At C, you'll get cutoff. At D, you'll get breakdown. You'll get great breakdown. So one after another, we'll discuss all these points. Now let's start with ohmic region. Look here carefully. So output characteristics curve, the region, the locus of the pinch of voltages at different value of VGS will give you ohmic region. Now this ohmic region, different ohmic region value, you'll get this for different value of VGS. For different value of VGS, you'll get different slope. So now let's understand this from the VGS point of view. Look here. Slope means what? Y by x, that means I by V, we know that is 1 by R. Listen to this carefully. VGS with varying VGS value, 0 volt, -1 volt, -2 volt, the varying VGS value, I'm varying the slope. That means with increase in VGS value, हम लोग decrease कर रहे हैं ना, 0 से -1 then -2, with decrease in VGS value, you are decreasing the slope. Slope यहाँ पे ज़्यादा था, then यहाँ पे कम हो गया, then slope is decreasing. With decreasing in VGS value, slope is decreasing in ohmic region. With decreasing in VGS value, slope is decreasing. So that is why, but your resistance is increasing. Understand this point? That means my resistance R is in the function of VGS. Okay, so the resistance of the JFET increases with decreasing in the value of VGS. That is why we called it as, so we can say this in this way: for different value of VGS, you'll get different values of slope. That means it is showing voltage variable resistance characteristic. Clear? So ohmic region, this ohmic region is showing voltage variable resistance characteristics. Okay, now let's go to the B section. Now in this B section, I'm only considering this B section. B section is your saturation region. That is, your ID value is constant. That is, after this pinch of value, you are getting constant current value. That means with increase in VDS which is greater than VP से आगे जो भी VDS value डालोगे, ये VP होगा ना, ये VP के आगे जो भी VDS value डालोगे वो आपको constant current देगा. That means JFET can be used as constant current source. Clear है ये point? So this region voltage variable resistance characteristics, ये है constant current characteristics. Which one? B part. Okay, now let's move to the third part. Let's move to this third part, that is this is C region. This is your C region. Now the value of VGS at which this value, the value of VGS at which your current value is 0. Okay, regarding this C point, you'll have a better clarity in the transfer characteristics curve. In this transfer characteristics curve, in the next video lecture, you're going to have a better clarity on this cutoff wala point पे. So तब तक के लिए आप इसको बचा के रखो. Now the value of VGS for which ID is 0, cutoff region और non-linear graph, you'll get a non-linear graph. इसके बारे में हम लोग next video lecture में पढ़ेंगे, ये clarity मिल जाएगा. Okay, so अभी के लिए आप बस इतना जानो, cutoff region. Okay, cutoff. So you get a saturation here, you get a cutoff here, you get a ohmic here. Correct. Now at D point, obviously we have discussed at D point your resultant electric field, which is E built-in और E electric field का resultant electric field का बहुत ज़्यादा effects है. आपका thermal generation of electron with increase in resultant electric field, you will get more and more thermal generation of electron hole pair, and just due to which you're going to have avalanche multiplication, and due to this you're going to have a breakdown. Okay, इसके बारे में हम लोगों ने डिस्कस किया था. So we have discussed four points. One is ohmic region, saturation region, cutoff region, breakdown region. Here it behaves like a voltage variable resistance, and this is varies as a constant current source. It is off, and it is a breakdown case. Now for this ohmic region, there is a small point which is called as your resistance. Let's analyze that resistance value, which is going to be very much useful for your engineering service exam. That is nothing but your channel resistance, that is RDS. Now look here carefully, it's a very simple thing. ये आपका 2D स्ट्रक्चर है, इसका 3D स्ट्रक्चर ये है. लुक हियर, ये P प्लस, ये P प्लस. दिस इज योर चैनल, ओके. चैनल का ये मिड पॉइंट है, मिड लाइन है. दिस इज योर चैनल, ओके. दिस इज योर चैनल, हाँ, ये आपका चैनल है, ठीक है. दिस इज योर डिप्लेशन विड्थ. दिस इज योर, ये कर्वी लाइन है आपका डिप्लेशन विड्थ, ओके. ये दिस इज योर P प्लस डिप्लेशन विड्थ चैनल, P plus depletion width channel, depletion width and P plus, depletion width and P plus. The length of this channel is L, and this is width ka depletion ka width is W, and from the midpoint of channel to the P का starting तक उसका वैल्यू है A, and इसका वैल्यू है B, and this is your drain. This value है Z. Now channel resistance RDS is given as V by I. The derivation is not in your syllabus, but this is in your syllabus. Please remember this value: L by 2AZ into ND into E whole into mu N whole into 1 minus VGS by VP का whole root over. Okay, now if VGS is 0, if you put this value is 0, then RDS will give a minimum value. That means that if you take that value as RDS on, so RDS on will be equals to L by 2AZ ND E mu N whole into 1 minus 0. In place of VGS we put 0, और कुछ नहीं किया हम लोगों ने, ठीक है. L by 2AZ ND E mu N whole into 1 minus 0. So from here you will get a value of RDS on. Now look here carefully, your RDS on is L by 2AZ NDE mu n. सो अगर ये एक्सप्रेशन में आप देखते हो चैनल रेजिस्टेंस में, तो ये जो आपका वैल्यू है ये आपका आ गया कितना, ये आ गया आपका कितना, RDS on. Yes or no? So instead of writing this much thing, you can write RDS on divided by 1 minus VGS by VP whole to the power 1 by 2. If you couldn't understand this derivation, in the description में ये है आपके पास, इसको फिर से रिवाइज करो, अपने हाथ से लिखो, कुछ नहीं है, बहुत सिंपल सी चीज़ है. ओके, नाउ लुक एट दिस फार्मूला. ओके, लुक एट दिस फार्मूला. RDS equals to RDS on divided by 1 minus VGS by VP whole to the power 1 by 2. Now यहाँ पे अगर VGS decrease हो रहा है, if gate to source voltage is decreasing from 0 volt to minus 1 volt to minus 2 volt to minus 3 volt, you can see your channel resistance is increasing. You can see here clearly VGS is decreasing. That means your channel resistance is increasing. That means channel resistance का increase होना मतलब करंट का वैल्यू डिक्रीज करना. देखो करंट यहाँ पे कितना था, फिर डिक्रीज हो गया यहाँ पे, फिर डिक्रीज हो गया यहाँ पे, फिर डिक्रीज हो गया. करंट वैल्यू यहाँ पे मान लो 5 मिली एम्पियर था, मान लो ये हो जाएगा 3, 2, 1 ऐसे हो जाएगा, क्योंकि VGS डिक्रीज कर रहा है. VGS डिक्रीज करने से रेजिस्टेंस इंक्रीज कर रहा है. सो दैट इज वाई इट इज़ इन ओमिक रीजन, इसलिए हम इसको बोलते हैं ओमिक रीजन में है. एंड JFET कैन बी यूज्ड एज वोल्टेज वेरिएबल रजिस्टर. Okay, so for different value of VGS, channel resistance will be different, and that is why JFET can be used as a voltage variable resistance. With this we are done with it's one of the most important video lecture of JFET, that is our output characteristics curve. Thank you so much for watching this video. See you in the next lecture of transfer characteristics curve. Till then, bye.